Stanford University.
Welcome to Stanford CS193P, winter of 2015. This is lecture number 9, I believe. And today we are going to turn on our clicker here, and then we are going to, I'm going to show you a very brief demo in addition to the auto layout demo that we did last time. I challenged you in that one to add buttons to your calculator, and then I didn't show you how to do that. So I'm going to show you how to do that, how in a different size class you could add some views that aren't in another size class. Then we're going to talk about our two big topics today. One of them is scroll view, okay, and the second one is multi-threading. And it kind of as a preamble to do multi-threading, I'm going to talk a little bit about closures. Now you should all have read your assignment, reading assignment, so you all know about closures, but I just want to emphasize something about them. That will start to be more important as we start using closures more for things like multi-threading. So let's make a quick little detour here. I'm just going to open up auto layout here. So here's auto layout, and what I want to be able to do is add another view only in one of my size classes. So here's my any size class, and let's say I go back to my any width regular height that we were working on. And let's say when we're in this particular arrangement, we want to have an extra button up here or something. And all we need to do that is to drag out whatever the extra UI you want is, like this button. And if you inspect the button with the inspector, right, attributes inspector, down at the very bottom, you'll see right here that there is some switches that control where this button appears. Now, since I dragged this button into this size class, it assumes I only wanted it in this size class. You see where it says installed right here? I could put it in all size classes by clicking this. That means it'll be in all size classes. Or I could take it out of this size class only by unclicking this. Okay? And you can add more things, like let's say in compact width, compact height, I want this button to be there or not. Okay? And that's true for constraints as well. If you have a certain constraint, like we've got constraints down here, like this one right here, that are only in this size class because these things are only down here in this size class. So you can see that's switched. So both whether something is even there and also the constraints you can control right here. And someone asked me, oh, I did all this work in here for this other size class, but I changed my mind. I don't want it to be different in that size class. How would I go back and undo all this? Well, the way you would do that is bring up your document outline, and you can select all your constraints. You can actually shift-click to select. So I could select all my constraints. And you can see over here in the inspector, it's going to show me that it's got a dash here instead of a check. So kind of some of them are there. And if I just go here and say boom and remove that, now all my constraints are only in my base class. There's no constraints that are just in this one. And in fact, if you look down here, look, all these constraints are all gone. So in fact, if I go here and update frames, boom, it goes back to the way it was. You see? Does everyone understand that? So constraints and the views can be turned on and off by just inspecting them in the attributes inspector. Okay, that's all I wanted to show you there. All right, back to the slides. All right, so let's talk about scroll view. All right, so this, you can see this iPhone right here. This is like, I don't know, iPhone 1 or something looking thing. But I keep it around because it's a really cool example of the power of scroll view and what you can do with scroll view, especially scroll views inside scroll views. So watch this little movie here go as we scroll around up and down. Okay, so that's just normal side-to-side scrolling, but there's up and down within a side-to-side. When I get to one, I can go up and down. And then this app at the bottom, I can scroll side-to-side at the bottom and also up and down. So you see how the scrolling can kind of go both directions depending on what you've scrolled into view. So scroll view is very smart about knowing which way you're scrolling and having all, opposing scroll views and stuff work properly. Okay, now we're not going to be able to have time in the brief time we have here to discuss how to make all that work, but I just want you to know the power is there. So someday if you want to build an app that has some UI like that, you know where to go, which is scroll view. So we're going to talk about the basics of scroll view, kind of how to get a scroll view to work. First, let's talk about how we add subviews to a normal UI view. So I got a normal UI view here, this white view in my iPhone here, and I want to add a subview to it. And so you know from lecture 5, I think, that I just create the frame, which positions it, and then I say add subview. Okay, so I got this view called logo, and it's just a UI view, or image view probably. And so I just add subview, and boom, it appears. Simple as that. That's really easy. So what is the analogy to doing this for scroll view? Okay, let's go look at that. So in a scroll view, if you want to add a subview, the most important thing you have to do is talk about how big the area you want to scroll over is. So you set this property in scroll view called content size. So here I've set my content size to 3,000 wide and 2,000 high. So I'm going to scroll over this huge space. Okay? Once you set the content size, now you can add subviews just like you do a normal view. So here I got a logo frame. I'm going to set its frame to way over on the left there, and I am going to add its subview. So I'm adding that subview to the scroll view. So, but instead of it like appearing on screen there, it's just kind of placed in this content area. And so I could add another one. Here's a huge image, aerial view of Stanford. And so I'm just going to set its frame and add it as a subview. Okay? So this is the fundamental, this is all there is to scroll view. It's really simple, actually. It confuses people for some reason, but it's really just this simple. You set the content size, then you add subviews to the scroll view. Now, the scroll view is just going to be a window on that content area. You see, it's just going to scroll around looking in that content area, and it'll see all the subviews as it moves around in there. Okay? That's it. That's all there's to scroll. It's incredible. Scroll view is incredibly easy to use. Now, you can reposition the views anytime you want, just like you could if they were subviews. You can just change their frame, and they'll move around. I change the logo's frame, move it around. I can also change the content size. Zoop, and now it zooms down. I've set the content size to be the size of the biggest subview. And now again, when I scroll around, it's just zooming around, okay? So it's very common in the scroll view, obviously, to set its content size to be the size of the biggest subview, so that it exactly contains it. Okay, now, as this thing moves around, you might want to know, where is it? Okay, what are we currently looking at in my content area? And you do that with the property in scroll view called content offset. And it's simple. It's just an XY offset from the upper left of the bounds of the scroll view. Okay? Now, what about the actual rectangle that's showing? What is that? That is actually the scroll view's bounds. Okay? It's very important to understand that that is just the scroll view bound. That yellow rectangle I'm showing you there, that's the scroll view's bounds. But if you want to know what that rectangle is in the content, like in that aerial view, what is that rectangle, then you have to convert it. You have to convert the scroll view's bounds using convertRect, which is a UI view method. You have to convert it to whatever view you want to convert it to, like the aerial view, whatever that aerial view is. Does that make sense? So that rectangle is the scroll view's bounds. Okay? Questions? All right, that's easy. So that's it. That's pretty much it to setting up a scroll view and knowing where the thing is scrolling. Couldn't be simpler, actually. How do you create a scroll view? There's actually numerous ways to do it. You can drag one into your storyboard. That's what I'm going to do in the demo. You can actually select a UI view in your storyboard and go up to the menu up there and say embed in scroll view, just like we did embed in navigation controller in a previous thing. You can, of course, create scroll views in code. They're just views, so you could UI scroll view, frame, whatever, and boom, you've created a scroll view. So they're just normal views. And then the code if you wanted to add those subviews in code, would look exactly kind of like what was on the previous slides, which is I might create an image view here. The green is just creating a UI image view, and then I'm just calling add subview. But if you just do these 3 lines of code, it won't work because you have to set the content size. If you don't set the content size, it starts out 0, and so you'll bring your scroll view up, and there'll be nothing there because you won't have that big white area to scroll around in. Okay? So no matter what subviews you add, if you don't have that big white area defined, then scroll view will not be showing anything. Okay, so it's simple as that. This is kind of just a review of what I showed you graphically. Now you can scroll around, the user scrolls around by just using their finger, right? They pan around, but you can scroll programmatically too by saying scroll rect to visible. And this will take a rectangle in the content area's view coordinate system, that content size, and it'll scroll the scroll view to be showing that. And animated is whether it slides over. If you don't say animated, it's just going to jump there, which is kind of abrupt to the user if it's on screen. And there's tons of other things you can do with the scroll view that I'm not going to really talk about, but you can lock the scrolling direction so it'll only scroll up and down or only scroll left and right. It'll flash the scroll indicators if the content size has changed. You can control that. There's a whole bunch of stuff. You can look at UI scroll view in the documentation. Okay? But I'm going to talk one important thing about scroll view, which is zooming. Because so far I just showed you kind of moving around. And of course, in scroll view, you can also zoom in on the content area. Okay? Zooming in requires you to do a few things, though. One thing is you have to set the minimum and maximum zoom scale. So the zoom scale is just, how much you'll zoom in. So if you have a zoom scale of 2.0, then that means that you will only zoom to twice the scale. And if you do 0.5, it'll zoom down to half or whatever the normal size of the thing you're looking at is. So you have to set these. If you don't set these, they'll be default to 1 and it won't work because the scaling will go from 1 to 1. Okay? And so that means not scaling at all. The other thing you have to do is use a delegate. So here's the second time I've showed you a delegate. Now I had you do all that work with the calculator to do the delegate so that you'd be ready to do things in iOS that use delegates. And here's one. Okay, you set yourself as the scroll view's delegate, and you implement this method. You have to implement this method if you want zooming called view for zooming in scroll view. So the scroll view, when it's zooming, it only zooms in the coordinate systems of one of its views. So usually it's kind of the background view. Like in that aerial example, it would be the aerial view that we would zoom in, okay? But we're zooming the whole contents, so everything gets zoomed, but that's going to be the view that you're zooming in. So you have to tell it which view that is. It's usually pretty obvious. Oftentimes in scroll view, you're only scrolling on one view anyway, but you still have to implement this, okay? You can zoom programmatically. Once you've set those two things up properly, then you can set the zoom scale, how zoomed in you are. It looks kind of like this. So here I've got a picture. If let's say my zoom scale is 1.2, I go to zoom scale 1, I zoom out, zoom back to 1.2, zoomed in. Okay? And same thing with zoom rect. So if I had a little rectangle like that yellow area and I said zoom to that rect, it would zoom to make that rect fill the edges as much as it could. Or if I had a rect that was really big and I said zoom, it would zoom it down to fit. Okay? So zoom to rect means make this rect kind of either grow big or grow small to fit. Okay? All right. There are tons of other delegate methods in scroll view. One thing when you start using scroll view you're going to ask me is, hey, scroll view has like 12 delegate methods. And when I say I implement the UI scroll view delegate protocol, how come the compiler doesn't complain and say that I don't implement those 12 methods? Because I thought if I said I implemented a protocol, I have to implement all those protocols. Okay? The reason that that happens, that you don't get a warning there, is because there is actually, for historical reasons, a different kind of protocol, which is an Objective-C style protocol. Objective-C was the old language that I was written in. And in the Objective-C style protocols, some methods in a protocol were allowed to be optional. Now that's not true in Swift, but that's true in Objective-C. So all these old delegate protocols like scroll view that have optional methods in them, Swift knows how to bridge them. You can actually create your own Objective-C compatible protocol with optional methods by saying @objc in front of your protocol declaration. So where you would say protocol face view delegate or face view data source, you would say @objc space protocol whatever delegate. And then you can put optional in there. And you can read, this is all covered in the rereading assignment, so hopefully you got that. But that's the magic that makes it so that when you say you implement the UI scroll view delegate protocol and you don't yet implement all the 12 methods in there, in fact, you only need to implement the ones you want, like view for zooming and scroll view. That's why that works. So anyway, there are a bunch of other delegates methods in there. For example, scroll view did end zooming. So that will be sent to you when the user pinches and then they lift their finger up. Okay? And it'll say, oh, the user has finished zooming and this is the scale they left it at. And you at that point might want to redraw your view to have more, be less grainy or something like that. If you do redraw your view at the new scale, you want to make sure you reset the transform. Okay, this property on view called transform is an affine transform. Really, that's all scroll view is modifying. When you pan around and zoom in, it's just modifying the property transform. So you can go look at the documentation for transform in view to understand what's going on there. Yeah, it makes scroll view really easy in that it just is modifying this transform. All right, so that's scroll view. So I have a demo of scroll view. We're going to learn some other things along the way while we're doing that. Okay, let's do that. Let's go over here. We're going to start from scratch again. So I'm going to create a new Xcode project. Okay, it's going to be single view. Those of you who like to follow along are not going to be able to today. Sorry, because I'm going to be dragging in a file with some URLs in it. I'm going to call this thing Cassini. Okay, it's going to be the name of my app. And I'm going to put it where I always put everything. All right. I'm not going to be doing anything with the app delegate as usual. I'm not going to be doing any image assets. I'm not going to do the launch screen. So here I just have a simple storyboard. I'm going to also get rid of all this view controller lifecycle here. I don't need that. Get rid of that. And so here, simple storyboard. Only has this one view controller in it called view controller. And I'm not even going to pay any attention to this view controller. Actually, I'm going to create a new view controller. I'm going to drag it out here. And this new view controller, its only job in life, it's going to display an image. So I'm going to give it the URL of an image, a JPEG file or whatever, and it's going to display it. That's going to be its job in life. So I need a new view controller for that. So I'm going to call this new view controller. All right, I'm going here, Cocoa Touch class. It's a view controller. I'm going to call it image view controller because that's what it does. It displays an image. Okay, very, very simple. I'm going to put it where all the rest of my stuff goes there. All right, so here we go. Again, I'm going to get rid of my view controller lifecycle there. We're going to actually add some of those back because part of the reason I'm doing this demo also is to show you a little bit where and why, how we would use a view controller lifecycle. So my image view controller, one other thing, I'll make sure in our storyboard here, we got this thing, I'm going to make sure I change the identity of it to be an image view controller. So this is an image view controller. Okay, it's an easy thing to forget, but we'll do that. Okay, so what do I need in my image view controller? Well, I need a UI image view. We saw that in the auto layout demo. It's just a view, kind of like a UI label for images. Obviously, if I'm going to have an image view controller, I need one of those. Now, I could just drag it out into my storyboard, but I want to use this demo as an example to show you how you create a view in code. Create and use a view in code. So instead, I'm just going to have a private var here. I'm going to call it image view. And it's going to be a UI image view. In fact, I'm just going to create it right here. Okay? So I have this image view. I'm just calling it there. Notice I'm not using the frame, so it's going to create this image view. It's going to be 0, 0 by 0, 0. It's going to be, its frame is going to be nothing. Now, it's not in any super view anyway, so it really doesn't matter what its frame is yet. Okay, it's obviously going to matter a lot once we start putting images in there. I'm also going to create a little private var here called image. And this is going to be a computed var. I did this in auto layout as well. It's going to be a UI image. And all I'm going to do here in the getter, I'm just going to return the image view's image. And in the setter, I'm basically just going to set the image to the new value. Now, why do I do this? Okay, I'm doing this for the exact same reason that I was doing it in the other one, which is that when the image is set in my image view, I want to be able to do things. I want to intervene. So I basically want to kind of be able to do the did set kind of thing to make that work. So what's my warning here? Oh, yeah. Oh, UI image. There we go. Okay? So in other words, right here, when this is set, when this image gets set, setting this image just is going to set the image in the image view. That's all it does. But I can put other code that I want down here because I'm going to need to do some things every time my image changes. I don't care about getting, but every time my image gets set in my image view, I need to do some stuff. You're going to see well, let's talk about what some of those things might be. For example, when I set it, I probably want to do image view size to fit. Okay? So when you change the image that's in the image view, this is kind of like saying label.text equals something, right? I'm changing the image view, the image that the image view is showing. When you change it, it does not change the bounds or the frame of the image view. So size to fit causes it to. So image view looks at the image, sees how big it is, and expands its frame to fit. So that's clearly something I want to do. Every time I change the image, I want to do that. So now you can see why I have this nice little convenience. You can kind of think this is similar to having a function called setImage, but it's just nicer to do it as a property because then I get set and get, and my code looks really nice. Okay, so there's that. I'm also going to do viewDidLoad. Okay, so viewDidLoad, we know that we of course need to call super. And what am I going to do in viewDidLoad? Well, I'm just going to add my image view to the view hierarchy. Okay, I'm going to plop it right here. I got my storyboard, got this thing, got my view as a top level view. I'm just going to add my view in here. Now I'm not doing a scroll view yet. Okay, I'm just going to do it without a scroll view so we can see what that looks like. So I'm just going to say view, add subview, my image view. Okay, and we know that this is fine to do because viewDidLoad happens after pretty late in the process. Now, I'm not doing anything here that's geometry based. I don't set any frames or anything like that. So this is just putting the image view in there with whatever frame it has, either from the last size to fit that it got, or it's still 0, 0, because it's never been set. Okay? So I'm just adding it as subview there. Now, let's talk about what the model is in this view controller. What is its model? I'm going to put the model right at the top here. Its model is going to be, and it's public, going to be a publicly settable model, which is an image URL. And it's just going to be an NS URL. So an NS URL is a class that holds a URL like http / some stanford.edu something. And that's going to be the model. And every time we set the model, it's going to get that image and put it in the view. Okay? Everyone understand our nice model here? This is a very well-designed MVC. It has a very clear model. It's clear what it does in its view. So one thing that whenever our model is set, though, we want to make sure we update our UI. So when if we set a new image URL, I'm immediately going to set whatever existing image we have to nil because we're changing it. And then I'm going to call a function fetchImage. Oops, okay, image. Okay, and fetchImage is going to fetch the image that's in the URL and load it up into my image view. So I need this private function fetchImage. Okay, so let's talk about how we get an image from a URL. If someone gives me a URL, how do I get the JPEG image or whatever that goes along to it? And it turns out to be quite simple. First, I'm going to make sure that my image URL is not nil. If someone asks me to load up nil, I'm not going to do anything. So I'm just going to basically ignore that. So if it's not nil, so my URL is not nil, I'm going to go out to the internet, or if it was a local file, it would be the local file, and get the image data. So I'm going to say image data equals, and I can do that with the class NSData. And you'll remember NSData from a long ago lecture, maybe lecture 3 or 4. NSData is just a bag of bits, right? So I'm going to reach out on the internet and grab the bag of bits, which is this JPEG file. And I do that by using contents of URL initializer here, and I just give it the URL. So I can go out and get that. Now, this could return nil. What if I just gave it some bogus URL? Okay, there's no file there. So let's check and make sure this is nil. So I'm going to say if the image data does not equal nil. Oh, why do I keep getting the caps lock there? Not really sure what I'm doing there. Image data does not equal nil. Then I can do something about it. Else I can't. So I could do if let, by the way, here, but I'm doing it this way for a reason. You'll see a little bit later. So if the image data is not nil, what am I going to do? Well, I need to turn that image data, that bag of bits, into a UI image. UI image is the class in iOS that represents an image. So that's really easy to do. I'm just going to say, in fact, I'm just going to assign it to my image. so I need self there. I would say image equals UI image with the data being that image data. Okay? Now, otherwise, I'm just going to say my image equals nil. Okay? And remember, this image equals something like this is just calling this right down here to set the image in our image view or whatever. Okay? And then, of course, this needs to be unwrapped. But we know we can unwrap it because I checked to make sure it's not nil. Okay, now, this line of code is a very bad line of code for us because it might go out over the network. Okay, I could be on cellular. This might take 10 seconds or a minute, or it might just fail because I have no network connectivity right now. Okay, so this is not a line of code we want to be executing in our program, but we don't know what to do about it right now, and I'm going to show you later in the lecture what we can do about it. So for now, we just got this kind of bummer line of code here that's going to be really slow. Our app is going to be really slow, although the network at Stanford here is so fast that it probably won't even seem that slow, but it will be slow because I'm going to grab some pretty huge images. All right, there's one other thing I want to show here in terms of view controller lifecycle, though, which is if someone sets my image URL, okay, and I'm not on screen, do I really want to go and start using up their cellular data plan? Okay? Probably not. Okay? You got to remember the people don't have Stanford Wi-Fi internet everywhere. Some people are using cellular, and it costs money. So I am not going to actually fetch this image unless I'm currently on screen. So how do I tell if I'm currently on screen? Actually, I can do that with view.window does not equal nil. Okay? So remember, view is our top-level view in our controller's view. And .window is the UI window it's in, which will be nil if it's not currently on screen. Okay? But there's a little bit of a problem here, which is, what if I'm off screen and someone sets my image URL, I don't fetch the image, and then I come on screen? Then I got to fetch the image. Okay? So where does that happen? Anyone want to hazard a guess where I would put that code? Nobody? View will appear, exactly, very good. So in view will appear, down here, I'm going to say super.view will appear. And then I'm just going to say, if my image is nil, then fetch the image. Okay? Now, it could be that my image is nil because I tried to fetch it and it failed, but it's just going to try again and fail. That's okay. But obviously, if my image is not nil, then I don't want to fetch it again. That would be wasting their cellular data even more. Okay, so here's a classic example of where we would use view will appear because we know it's worth it to go get that data because we know we're going to appear on screen. Okay? Everybody understand that? View controller lifecycle coming to life for you? Okay, so that's good. So let's go ahead and run. See, actually, let's go ahead and put a default image in here. I actually have some URLs. I'm just going to drag this demo URL .swift in here. And all this demo URL.swift does is it just defines a bunch of URLs, okay, that we're going to use in our demo today. So one of them is Stanford right here. So I'm going to load that up. So in my view did load, I'm going to say if my image is nil, then my image URL equals my demo URL.stanford. Okay, so I'm just going to, in view did load, I'm going to set my image URL. Now, it's not going to actually load this until it will appear. That's okay, but I'm just setting it right here. Okay? And I'm not, this is really for testing anyway. I probably don't even need to do that, just because we're going to remove this code once we start really not testing and actually working. So let's go ahead and run this and see what we got. Oh, so it's not going to work. Okay, so this comes up. It's blank. Why is this blank? Well, let's look at our storyboard. Here's the entry point to our storyboard. It's this blank view controller. So we don't want that. Let's move over here and have it come into our view controller, image view controller here. Oh yeah, there we go. We got Stanford. That's very nice, but can't scroll around. Okay, whoops. Can't zoom. Okay, I'm trying to pinch. Oh, nothing. Okay, so I can't see it. Okay, can't see anything. So that's obviously, we need a scroll view. All right, so let's go ahead and, first of all, actually, what should we do first here? Let's do, let's enhance our user interface a little bit more so we can pick other images. I don't want to just have this Stanford image. I want to have some different images that we can look around in. So I'm going to go over here and drag out a split view controller. Where's that split view? Right here. So let's drag out this split view controller. And as usual with the split view controller, I'm going to, when I zoom out a little here, we can look at it. I'm going to delete a lot of the stuff that came with it here. Keep that one. We'll delete that. I'm going to have my image view controller is going to be the detail. Okay, so I made the detail. I'm going to make my entry point here be my split view controller. And I'm going to have my master be this little one that was in here before. By the way, I just control drag there and set this little view controller that was there when we first started our app, this blank view controller. I can set it as the root view controller of a navigation controller with control drag and pick root view controller here. In the demo and in your thing, you probably did this editor embed in navigation controller, but you can also do it with control drag. Okay? So now I have a nice UI here. Comes up, shows my nice image view right there. If I go back, here's my master. So now in this master, I'm going to put some buttons so we can pick different images to look at instead of just looking at that Stanford thing. So let's do that. Really easy. I'm just going to grab some buttons here. Let's do this. Let's make the buttons really big. Maybe like 48 point. Okay, this button's bigger. And let's make 3 of them. Okay, one of them is going to be a picture of the Cassini satellite, okay, that was sent out past Saturn. Another one is going to be a picture of Earth. Another one is going to be Saturn. Okay, so let's do a little bit of our favorite thing here, which is auto layout. So put that one right in the middle. Put that one right underneath. This one right on top. Okay, I'm going to try and reset to suggested constraints and see how that works. That didn't work very good. Let's undo. I think that's because, let me make this thing be its normal size. That's why. There we go. Okay, put these back. Hopefully this will, there we go. Reset to suggested constraints. Oh, still didn't work. Okay, well, we'll fix them up manually. So this guy right here, oh, that's so bad, it's not even close. Okay, so I'm just going to do this all manually here. I'm going to, sorry, wrong thing there. Okay, control drag. Let's make it center vertically. Let's control drag and center horizontally as well. Let's make this be vertical spacing. We'll make this one be vertical spacing. We'll have these things share their center X. Center X. I think we're good to go there. Yep, frames. So let's update our frames. Missed. Okay, there we go. All right, so we've got some nice auto layout there. And so now all we need to do is to segue. When these are pressed, we're going to segue to our image view controller down here. So let's set that up and just control drag. No, control drag. All right, so I'm going to show detail because in the split view I want it to show up on the detail side. And on iPhone it's going to push. So there's that one. Let's go ahead and set its segue. So this one, I'll just call it Earth. Okay, this one down here, show detail. We'll call this one Cassini. And with this one, show detail. We'll call that one Saturn. Okay, so there we go. We've got a nice storyboard here. We've got these segues all set up in here. All we need to do is prepare for these segues. This view controller right here, okay, I'm going to select on this and go here to see its code. So here's the code for that view controller. It's just this blank one that got created when we created our app. Okay, and all I need in this view controller is prepare for segue, nothing more. So I'm going to prepare for segue. Actually, I'm going to make this quite a bit wider here with these huge fonts. And in here, I'm going to see if it's a segue to an image view controller. So I'm going to say if I can let image view controller equal my segue's destination view controller as an image view controller. Okay, so we know we're segueing to an image view controller. Then if I can let the identifier equal the segue's identifier, so the identifier is not nil, then I'm going to switch on the identifier. This code should all look very familiar to you. And then in case of Earth, okay, we are going to have to set the image URL. Okay, so IVC is an image view controller. Its public settable model is the image URL. So I'm going to set that to demourl.nasa.earth. Okay, I have a nice one ready to go there. I'm also going to set the title of that to Earth. Okay, and then same thing here for Saturn. It's image view controller's image URL equals the demo URL.nasa.saturn. IVC.title equals Saturn. And same thing for Cassini. Oopsie. Okay, and otherwise we will just break and do nothing. Okay? Everybody understand this code? Hopefully completely familiar to you, nothing special there at all. Okay, so I think that should work. Let's try it. Hopefully didn't forget anything. All right, so we go back. We've got these things. Let's go ahead. Oh, my auto layout doesn't look very good there. Probably messed that up, but anyway, close enough. Let's go Earth. Oh, it didn't work. Okay, that's because we have back here in our image view controller, we have this test code here. Let's get rid of that. Right there. Try again. All right, back now. Let's look at Earth. And look how slow this is. You see what I'm talking about? It's like, hello, hello. Can't do anything. Click on any buttons. Finally, we get this. This does not look like the Earth to me. It looks like a bunch of dim photos. I don't know what that is. How about Cassini? Oh, well, we got the outer space part of Cassini, right? But that's all we can see because we need the scroll view now. We absolutely have to have the scroll view. These are big images, so we can't see anything without it. So let's go back and put our scroll view in here. All right, so how are we going to put the scroll view in here? Well, I'm actually going to put the scroll view in using the storyboard. So I'm going to drag a scroll view in. That's kind of a simple way to do it. So let's bounce out here. So now we're back to our image view controller. All right, this is our image view controller. And I'm just going to drag out a scroll view. I'm going to search for it. Scroll. There it is. Drag it out here. I'm going to place it so that it's right on the edges with the blue lines right there. I'm definitely going to do reset suggested constraints. I'm going to make sure that worked, which it did. Okay, no magic numbers. Everything looks nice right there. And now I just need to put my image view inside this scroll view. Right? So I got this scroll view here. All I want to do is put the image view inside of it. So how am I going to put that image view inside of it? That's very, very, very simple. I'm just going to create an outlet to this thing. Let's put the outlet right here. Okay, I'm going to call the outlet scroll view. And as soon as that outlet is set, in its did set, I'm going to simply say to well, actually, we already add the scroll view. Let me make this a little easier. See right down here where we add the image view to our view? Instead, I'm just going to add it to the scroll view. Okay? So you can build your view hierarchy in view did load. It's actually a pretty good place to build it because all your outlets are set, so we know this is set, and so we can build our view hierarchy here. Okay, so I just added this subview to there. But I do actually need this did set here. Let me again make this wider so you can see it. Because when I set my scroll view, what's the most important thing to make a scroll view work? The content size, right. So when my scroll view gets set, I need to set the content size. So I'm going to say scroll view.content size. And what size do I want it to be? Well, I want the content size to be exactly the same size as the image view. So I'm just going to say image view.frame.size. Okay? Now, that's not, oops, equals. That's not the only place I need to do this, though. Okay? Anytime my image changes, obviously my image view might change. I need to change the content size of my scroll view. So also here, inside the setter for image, I need to set my scroll view's content size equal to the image view size, frame size. Here I'm going to do something kind of interesting, which I actually did in auto layout demo after the fact when I posted the code. But I'm going to put a question mark right here. And the reason I'm going to do that, it allows me to set my image internally even if my outlets have not been set yet. And I know that these outlets are implicitly wrapped optionals, and of course that means you can access them, but the reality is you need to protect against the cases where those things might be nil, like setting your image somehow before the outlets are set. So now I don't need to do it here because I'm in view did load, and I don't need to do it here because of course it just got set, but here I'm going to do it just to be safe. Everyone understand that? Okay, so let's see. Should work. All right, here we go. Let's go try Cassini. Slow. Okay. Oh yeah, look. Oh, stars. Anything? Oh, what's that? Oh, look at that. Oh, sorry. There it is. Oh. It's a spacecraft of some sort. Hard to tell. Okay, we don't really get to see a lot of it, but it kind of might be Cassini. Okay, well, obviously we need zooming, okay, because I can't see really what's going on here. All right, so let's go back and add zooming. Again, very straightforward. Remember, there's only two things you really need to do. You got to set that min max, and you got to implement that delegate method. Great place to set delegate methods, of course, is in the setter of outlets if you want to set the delegate of an outlet. So I'm going to set the scroll views delegate to be myself. Of course, I'm going to have to say that I implement it. That's the problem here. Okay, we'll do that in a second. While I'm here, I'm going to set the minimum zoom scale to 0.03. This is a very, very large image that we'll be able to look at here. And the maximum zoom scale to 1.0. And maybe these don't want to be magic numbers. Maybe these want to be based on the actual size of the image view. Okay, so you might want to make it so that you can perfectly zoom out to fit the scroll view or something like that. But I'm just picking numbers here to make this code simpler. So let's go fix the fact that about the delegate here. So I'm just going to go up here and say, oh yes, image view controller is a UI scroll view delegate. And as soon as I say that, this warning went away down here, but I didn't get a new one that said, oh, you don't implement this. And again, because this is the old Objective-C style protocol where there's optional methods. So I'm going to implement one of them, though, which is view for zooming in scroll view. Okay, as soon as I typed view for, it knew what I was talking about. And I'm just going to return my image view, because that is the view that's inside the scroll view's content area that I want to zoom on. And that's it. That's all we need to do. So let's go run. Now we should be able to go and take a look at Cassini and all of its grandeur. I'm just going to hold down Option so that I can pinch, and I'm just pinching in here. Ah, there it is. And let's go ahead and rotate the other way. There we go. So we can see it. And zoom out a little bit. We can still scroll in addition to zooming. Okay? And let's go look at this Earth thing. See if we can figure out what the heck is going on with that. So slow. Okay, so here it is. Oh, now we can move around and look at things. Let's zoom in on this a little. Let's see if whoa, it's the Earth. Woo. Okay. So, yes, and as we can imagine, guess what this one is? Pictures of people. So this is actually made up of composites of images of people waving at Cassini. Okay, they're taking pictures of themselves, waving. See? Hello, Cassini. So that's what this composite is made of, and they made a picture of Saturn out of there. Okay, so NASA, pretty cool. All right. Okay, so that's good. So that's all I'm going to show for now. We'll get back and work on the fact that our app is really, really slow in a minute. Got to show you some stuff first, though. Okay, any questions about that? Scroll view, really easy to use, but you just got to know these particular things like the delegate and that min-max zoom scale and that content size. As long as you do those things, it'll work really great. All right, so a little aside here, just a 2-minute aside. I'm going to rip through these slides about closures, but there's an important aspect about closure that you need to know. Okay, closures, when you have a closure in your code, it captures any variables that are used inside the closure from the outer scope where the thing is, which is really cool feature. That's what makes it a closure, really, okay, is that it captures them. Okay, you can make incredibly elegant code out of this. Okay, now here's where I'm going to show you something about the calculator that if you didn't do this in your assignment, that's good, because in your assignment I wanted you to use delegation. Okay, however, sometimes closures can be a substitute or a better tool to use than delegation. Let's look at this code right here. Let's say I have a class called Grapher. I'm not going to say what kind of thing it could be because some of you haven't turned in your homework yet, but let's say I had a Grapher, okay? And it doesn't have a delegate method or anything. It just has a var called y for x, whose type is a function that takes an x and returns a double. Okay, now it's an optional function. That's fine. Doesn't have to be set in this grapher. And then what if I just said, well, I'm going to let the grapher equal a new grapher. I'm going to let variable graphing brain be a calculator brain instance I just created. Then I'm going to set the program of the graphing brain I just created to some other program that I want to graph. Then I'm just going to say y for x equals a closure. And inside the closure, it just says set the variable value to the argument to the closure, and then return the graphing brain at evaluate. So do you see how by using this, first of all, we have grapher is completely generic, knows nothing about a calculator brain, and yet we have this 6 lines of code to implement our graphing, and it's all incredibly easy to kind of parse what's going on. Now this works because the closure, that little thing in the curly braces, captured the graphing brain that I created, okay, so that every time this closure is called, every time grapher wants y for x, it keeps reusing this graphing brain over and over and over, which is exactly what I want, because this graphing brain's got the right program in it, it just keeps calling it over and over. It doesn't create a new one every time, it just keeps reusing it because it captured it from the outer scope. Everyone understand what I mean by capture? Now, this is really cool and really elegant, looks really awesome. It is awesome, but there's some dangers, okay? Capture danger, okay? The problem is if a closure captures a pointer to something and that something has a pointer back to the closure, now you have a loop, a memory cycle that's going to keep them both in memory forever, okay? Kind of like the other memory cycle we were talking about before. This is easy to have happen in a closure. Okay, so this is what it looks like. So here's another example here of closures. I've got this class called foo. It's got one property, which is a function called action. It's got another function called show, which just takes an integer and shows it, prints it, println. And then it's got a method called setUpMyAction. And setUpMyAction has a local variable x, which is an integer. And then it assigns that action function property to a closure. And inside that closure, it uses the x. And that's cool. It captures x. And so this will actually work. This will print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see the do my action 10 times at the bottom. It will, if you set up my action, it will do it because the x gets captured by the closure. And every time the closure gets executed, it increments that x and counts to 10. It's also cool because it's capturing self, because I'm using myself to show the number by calling self show. But here's where the danger comes in, okay? Because self has a pointer to the closure. And the closure inside has a pointer back to self. Now, when you write a closure, you'll notice that anytime you call methods, it makes you put self. It makes you say self dot. That's because it wants you to be clear. You are capturing self when you call show, okay? Now, this is a problem. Foo, this class foo, and this closure are pointing to each other. They will stay in memory forever. They can never be released. So how do we fix that problem? Well, we can actually say, when we make a closure, do not capture this variable in here. Okay? And you do that by saying unowned, whatever the variables you don't want to be captured. Okay? You just put it right at the beginning of the closure before the in. Okay? If you have arguments, you put it right before the in there. And that will make it work. You can also say weak self, which is a little different. That'll make the self be a weak pointer in there. We learned about weak pointers in the lecture when we talked about delegation. So weak would work too, it wouldn't do it. The difference between unowned is unowned that pointer doesn't have to be an optional that can be set to nil. It can just be anything. You just guarantee that self will never become nil. So for the lifetime of this closure, self can never become nil. Okay? Now, self can be released from the heap, which will release the closure now from the heap. That's great. But that closure can never be executed while self, this foo thing, is nil, which is fine because it's only used inside foo. That would never happen. Okay? So unowned self. So this is all covered in the documentation that you're supposed to have read, but you might have not really understood this or glossed over it, so I'm just revisiting it to tell you that it's important. Okay? Because we're going to start using closures more and more in this class, and you will be capturing values, and some of them will point back to the closure. Okay? Okay, that's it. Next is multithreading. Okay? Yes, question?
Is there an example, could you give an example other than self where it would point back?
I think that Swift reference document has a whole big long example, so I would refer you to that. Any other questions about that? Okay, multithreading. So how many people here have done some programming in a multi-threaded environment before? Okay, so more than half. That's more than usual, so that's good. All right, so then this will all be pretty easy for you to understand. Those of you who haven't, it will be a struggle. If the first time you do it, I'm sure all of you can attest, it's a little bit hard to understand what's going on. But it's actually fairly simple. What's going on here is, in iOS, there are multiple queues, a queue meaning like a queue at the movie, right, where people are lined up to go see a movie. A queue, in a computer science sense, is just a list of things where things go into the front of the queue, go into the back of the queue, rather, and they get pulled off the front. So there's a queue of functions, basically closures usually, okay, that are sitting there waiting to run. And each of these queues has its own threads to run these queues, to process the things on the queues, okay? So that makes this a multi-threaded environment. Now, there's a very, very important queue called the main queue. And this main queue is a serial queue, meaning it pulls these functions off the queue one at a time. It never runs two of them at the same time. Okay, they're serial, one at a time. And all UI activity has to happen on the main queue. So if you ever wanted to have a function, a closure, that is executing some code that did anything with the UI, you have to put it on the main queue. It can only execute on the main queue. This is how, basically, the UI is protected from getting messed up in the multi-threaded environment. It has this main queue. Okay, so the main queue is very, very important. The main queue never wants to be doing anything that might block, like NSData contents of URL. That should never be in the main queue. So we're going to have to get that off the main queue. All the code that you write normally in your MVC, that's all happening on the main queue. Right? View did load, view will appear, all that stuff's all happening on the main queue automatically for you. You don't have to do anything special. Okay? But there are other queues that iOS will create for you as you need, and we're going to show you how those work. So first of all, how do you execute a function or a closure on another queue? Well, you do that with this function called dispatch async. Okay? So you say dispatch async. The argument, there's two arguments, a queue and a closure. So the first argument is the queue, and I'm using the trailing closure syntax here to put the closure outside the parentheses there. But you just specify what queue you want to execute the closure on, and then you pass it the closure. Okay? And the closure takes no arguments, returns no arguments. And that's it. That's how you do it. Couldn't be easier. Dispatch async on the queue you want. So how do you get the queue that you want? Well, you get the main queue using this function dispatch get main queue. And that returns the main queue. There's also an object-oriented way to do it, NSOperation queue.main queue. And so you got this queue, and so here's an example of putting something on the main queue, dispatch async, not the main queue, something, and then inside there, you can say dispatch async main queue. So this is how you do multi-threaded programming, those lines of code right there. So I want to do something that doesn't block the UI. So I dispatch it to not the main queue, some other queue. I'll talk about how to get those queues in a second. Then I do it, go do something like NSData contents of URL, blocks, whatever. And when it's done, Now I need to talk back to the main queue to like update my UI with the image I got or something like that. And the way I do that is I dispatch back to the main queue. So you nest these calls to the dispatch. Okay? So you're basically running code on another queue, and when it wants to talk back to the main queue, it just posts or puts some code back on the main queue. And now the main queue might be busy, but when it's done, it's a serial queue, but eventually it will get to this block and it will run it. Okay? Everyone understand that? And that's it. It's so simple, really. Actually, when you see it, it's almost too simple, the code, when you write it. It's like, it's so simple you can get confused and forget that you're in a multi-threaded environment. But this is really, those lines of code you're seeing right there at the bottom, that is the fundamental multi-threaded programming syntax in iOS. So how do you get these other queues, right? You don't want to run on the main queue. There's really, you get a queue from the system by asking for a certain quality of service. And there's 4 qualities of service. There's user interactive, which is, I'm going to do something off the main queue, but the user really wants this done fast, and it's not going to take very long. So do it right now. Okay, so it's a high priority queue for things that go really fast. Then there's user initiated, which is, okay, the user just asked for this, but I know it's going to take a long time, like fetching an image off the network. That's we would use user initiated. But it still is pretty important. Then there's utility, which is I'm just doing something. The user didn't just ask me to do this, but it's just something I need to do in the background or processing things or whatever. But it is something that matters right now to the user, so it would be nice if it returned somewhat soon. But it's not like, oh, I got to have it. And then there's background, which is like things that are not concerned with what the user is doing right now. Like, oh, I'm prefetching some data, updating some database, cleaning up a database, doing stuff in the background that really has nothing to do with what the user is doing now. You understand what I mean? Just background tasks. So you create a quality of service. You do that with this really odd int, one of these constants above there, .value, close parentheses, okay, for historical reasons. They haven't put a nice new UI in there for Swift, which is interesting. But anyway, you do that. And then you just say queue equals dispatch get global queue with that quality of service, comma 0. That comma 0 is reserved for future use. Okay? And that's it. Now you have another queue. You can now dispatch async to it and be running code off the main queue. Simple as that. You can create your own serial queues too. I'm not going to talk about that really, but you might have something where these queues that I talked about at the top, these quality of service based ones, are concurrent. So actually a single queue, like the user interactive queue, could actually have multiple threads working at the same time. If you had a multi-core processor, they could even actually be working on them. But mostly it's time sharing, time slicing between the various threads. But anyway, you can do a serial one, and you would do that only if you want to do something off the main thread that something depends on the next thing, which depends on the next thing, so you want to do them serially, or you want to throttle. Like you're fetching a bunch of images, but you don't want to bombard, you know, Flickr or whoever you're requesting the images from with hundreds of requests. You're just going to do them one at a time, and they're going to appear in the UI one at a time. So you can do your own serial queues with create queue, dispatch queue create. Okay. You can also use the multi-threading stuff to do something in the future. Okay, you do that with this dispatch after. It's kind of odd. Again, the arguments are kind of weird. You do this int 64, delay in seconds times double nsec per msec, seconds per millisecond, dispatch time, now, delay, blah, blah. You create this basically time, this dispatch underbar time, t, that is in the future, and then you just say dispatch after that amount of time, onto the main queue. So you're almost always doing dispatch after on the main queue. It's rare that you're doing on another queue because that other queue, those other queues are kind of concurrent running queues and such. Anyway, it's more likely, you know, I want to put up an alert in 10 seconds if the user hasn't done something or something like that, which is kind of weird UI, but anyway. You never want to block the main queue saying, oh, wait, 20 seconds, and then I'll do this. But you want to be able to notify it. And there's tons and tons of stuff that I'm not even going to talk about, but you can do readers and writers. You can protect critical sections of your code doing this. You can do synchronous dispatch, okay? Instead of asynchronously firing these things off to put on the queues, you can wait for them to execute. All that stuff. You won't need any of that for this class probably. The things I showed you, that's the basics of it. That's probably all you're going to need. Okay? There are some APIs in iOS that are multi-threaded. So you got to be careful. If you're doing something and it seems like, this might be multi-threaded, this seems like it might take a little while, like it's going to access the network or something like that, then you want to read the documentation and see, is it, are you giving it a block, for example, that's going to be executed off the main thread? Because in that block, if you want to do something with the UI, you have to post back to the main thread. Okay, so this is what that looks like. For example, here is an API. This is the NSURL session API. The thing in yellow is all that really matters. It lets you download a file from a URL, and it does it asynchronously. And you give it a block, which is the completion handler. So when it's done, it invokes your block. And it's got some arguments there. It moves the file to a local URL that you can open. You get HTTP response, you can error, et cetera. And so you want to do something in there to update the UI because you got the file back. And can you? No, you can't because that's not on the main queue. However, you can put dispatch async in there. Okay, so this is exactly the same code. I just added dispatch async in there. All right. So that's an example where you dispatch async. This is exactly the same thing as I showed you on that very first slide. It's just that it's wrapped inside an iOS API instead of just your own dispatch to another queue. Okay? All right, so again, a demo's worth 1,000 words. So let's go look what it looks like to make an Imaginarium there, or Cassini, I guess I called it this time. Let's make this thing be multi-threaded. So we know that it's really bad UI. It blocks every time we ask for these big images. It's completely stuck. So we need to, where we fetch the image right here, we need to go do that, be doing that on a different thread. All right, so how are we going to do that? Well, we're going to do exactly what I did in the slides there, which is I'm going to create one of these quality of service things here. Okay, first of all, I don't need to do anything if my image URL is nil. So if it's not nil, though, then I'm going to let my quality of service equal, let's go ahead and do this so you can see lots of code here. All right, I'm going to select this quality of service to this weird thing, int. And the quality of service I want is going to be this user initiated, because the user has asked for something. It's not going to be quick, but I want it to be done as soon as it can because the user's waiting for it, basically. So that's going to be my quality of service there. And then I'm just going to say dispatch async. The queue I want is a global queue, so I'm going to say get global queue. I'm going to actually use a different one of these. Hold on. Additional global queue. Use this one, okay, which is the one that takes the quality of service there. So quality of service, not caps, QoS. There we go. The flags are always 0 there, and here's my block. Okay, so let's double click to do that. I'm going to put that outside, the trailing closure syntax here I'm going to use. Now inside here, now I can do the things that's slow. So let's put all of this inside here to start, even though we know that's not going to be good. All right, so I dispatch async in here. Notice that it's already complaining that you've got to put self in here. That's because I put this inside of a closure, and it's capturing self because I'm accessing my image var here. All right, so I can fix that one. Let's go ahead and do that here as well. That's extra parentheses. OK, so that's good. Now, this is fine. This is that thing that's going to be slow. It's happening on another thread right now. That's great. But this is not great because here, this is going to cause UI stuff to happen all over the place. Right? Look at all this UI stuff it's going to do. So I cannot do this on this thread. So I just have to dispatch it back to the main thread. The main queue, actually. And again, I'm going to use the trailing closure syntax there. That's exactly why they designed it that way. All right, so now I'm dispatching back to the main queue. That's good, and all is well. And that's it. That's all it took. So you can see the multi-threaded, it's like absolutely they've made it so it's like, except for this weird, this int thing, they've made it about as minimal amount of code as it can possibly be. Okay? All right, so this is not quite right. We're not done here, but let's go see if this fixed our problem at least. So here we are. So I'm going to go earth Now look, I can go back. My UI is completely active. I can do anything I want, even though it's still loading that thing in the background. Okay? And eventually, once it's kind of sucked it all down, it shows it to me, and I can zoom in on it. Here we go. Okay? So that's exactly what we want. It took virtually no code on our part. However, it's not quite right. And if you have experienced multi-threading, you're going to immediately understand what I'm talking about here. This is kind of lulls you into thinking, oh, I got this right. OK, ready to go, next problem. But what happens if this image data takes a long time to come back, and in the meantime, the user asks for a different image? OK? Well, our UI can't do that, of course, because we segue to and from, so we're always creating new MVCs. But imagine you had an MVC that stayed on screen, and there was a way to click a button, and it would load a new image. Well, this thing might come back after the next request and show the user the old image they wanted instead of the new one they'd asked for. Do you see the problem? So this is where multithread gets a little hard on your brain. It's like, oh, what? Well, these things are happening in different order because they're happening in different threads of execution here. So how do we fix that? It's actually fairly simple to fix. When this image data comes back, okay, we're just going to check and see if the URL that caused it to be fetched is the one we currently want. So I'm just going to go here and say if the URL, which is this URL right here, which was captured by this, okay? So if this URL up here equals self.image URL, in other words, the URL that my user currently wants, okay, then I'm going to do this. Otherwise, I'm going to completely ignore this response. Okay, this JPEG file came back, but the user has moved on. They don't even care about this. So you see what I'm talking about, where you got to think a little bit with this multi-threaded. You can't just throw the code in there and go, oh yeah, it works. You have to think about things might be happening, taking a long time, okay, because they're happening separately. Okay, so that's good. There's really nothing to show there because our UI doesn't really allow us to specify a different image. When we click back and forth in our UI, we're creating a new MVC every time because we're segueing. So the new MVC has obviously got its own environment. So the last thing I want to show you is our UI is not very good because it has a lot of blank white screen in it. Okay, right here, blank white screen. It's like, oh, blank white screen. What's going on? I don't know. What's happening here? I don't know. You see what I mean? It's like I can't even tell what's really going on in my UI. It'd be nice if when I clicked here, I got like a spinning wheel that would say, I'm working on it. I'm trying to get that thing. Okay? So we want a nice little spinning wheel in here. So how do we do the spinning wheel? Spinning wheel, very easy to do. We're going to go to our storyboard right here. Screen real estate management is a challenge on this small screen. And I'm just going to drag out a little spinning wheel into my UI. And this is a great chance for me to show you a little bit of how to use the document outline. You'll see why. So here, the spinning wheel is called the activity indicator. So I'm going to type activity. There it is, little spinning wheel. Drag it out. I'm going to put it here. Now, when I drag that out, it kind of looks like, oh, OK, good, worked. Yeah, got a spinning wheel on there. I'm ready to go. But actually, something very bad happened when I dragged that out. And if I look in the document line, I'll see what it is, which is that this spinning wheel was added as a subview of the scroll view. Because I dragged it out on top of the scroll view, so it added it as a subview. So that means it's going to be in that content area. We don't want that. We want this thing to be floating on top of the scroll view. So it's very hard to fix it in here, because it's like, where do you drag it? The scroll view is everywhere. You know, you can't get it. So this is what the document outline is great for. Watch this. I'll take this right out of the scroll view. Boom, it's out. Now this puts it behind the scroll view, because I told you the subviews list, the top things are in the back. So I'll just put the scroll view on top. So now I have the scroll view in the back, indicator in the front. Okay? What about constraints? Oh, the constraints here are hard to put too, because every time I kind of drag, it keeps dragging it to the scroll view. Well, I can do constraints in here as well. Let's drag the indicator view up to the view above the scroll view, right? Our MVC's view. And I'm just going to say I want this to be centered horizontally and vertically in that view. Boom, I've set the constraints now for that, totally using the document outline. Now let's do one other thing with the indicator. I'm going to inspect it over here. And you can see the indicator has some different styles. We like gray because we have a white background, so that's good. But it also has a couple buttons here, and this is a good one to click, hides when stop. That makes it so when the spinner stops spinning, it hides itself. So it's only showing while it's spinning, which is kind of a nice feature. You can cause it to show and hide yourself, but it's nice to have it hide itself. All right, so we have this nice little spinner here. So let's go ahead and hook it up into our UI, and I'm just going to control drag. Even control dragging from this can be a bit of a pain because it's very small and you got all these constraints in the way. So you can actually control drag from over here. All right, so I'll control drag. I'll put it right here. I'm going to call it spinner. I like to call my activity indicators spinners, but you could call it activity indicator too. So here's my spinner. And what do I need to do with this spinner? Well, I just need to start it spinning when I make a request, and then I need to stop it spinning when the request is fulfilled. Okay, so how am I going to do that? Again, I want to get lots of room here. All right, so I got my spinner. Well, where do I make a request? Let's see, it's right here. Right? This is where I dispatch a request. So I'm just going to say spinner start animating. But I'm going to make it even better. I'm going to say question mark in case we're fetching an image before our outlets are loaded for some reason. We don't currently do that because we only do it in view will appear. But someday someone might write that code. And then I could stop the spinner like down in here, but actually a great place to stop the spinner is as soon as an image is set. Anytime an image gets set, I don't want to be spinning by definition, right? So I'm just going to say spinner dot stop animating. Okay, that's it. That's all it takes to do the spinner. So let's go take a look at the spinner spinning. All right, so the spinner didn't spin at start because I haven't made any request. But here if I make a request, there's the spinner spinning. And yeah, you can make the spinner larger if you want. But it's spinning because we're still working on it. And once the thing appears, now my spinner is gone. It's kind of hard to tell in the dark spots, but here in the light spots you can see that our spinner is gone. Okay, same thing, we come back, click on this one, spinner comes back, right? And I can't scroll it, there's no scrolling or anything like that.